So this is what phi is supposed to be. You don't have to write it down. I made the mistake of reading the wrong asymptote here. I read it as a -3 instead of a -4. And then I used this wrong ordered pair on the curve. I should use the ordered pair that's right after my intersection of my asymptotes. So, moral of the story is, thankfully in the homework, they'll always give you the point that's right after the intersection of asymptotes. That's good. And that's why it fooled me, because they always gave me the right point I could use for the shortcut, but they didn't in number 5. So, and there was another misspoke. Up here we were talking about, how that flipped the graph, that negative on the 2. Okay, I said it flipped across the y-axis. Wrong, wrong, wrong. So on your notes, please, if you did write this down, this flips the graph over the x-axis. So change your y to an x. And the reason that's such a tricky wicket is because they look the same. And this negative, the reason I made the mistake, I just was wrong. But this negative isn't multiplying next to the x, it's multiplying outside the x territory. Even though it's multiplying within the fraction story, it's not next to the x. So that's why I did it. I had it incorrect. And it just takes experience and mistakes and more experience and more mistakes. But if you graph this on Desmos to see which one it flips over, you can't tell. You cannot tell because they look exactly the same when you put it in Desmos, wherever the negative lives. So that it's, I want to say it's semantics, really. Does that make sense? It's just, who do you want to say flip? Because it doesn't make a lick of difference on the values. Okay? My apologies. Thank you for letting me own my mistake and correct it. So the actual homeworks, the first 8 problems are just saying what happened to the graph. Then the last 9, 10, 11, 12, 13, 14, 6 problems are actually doing the graph thing. So we just did the most difficult problems on the homework, working through that, those notes before we wanted to get into the homework. I did not want to start the homework without you seeing the picture of a parent function in a rational function. So here we go. See if I'm zoomed in too much. I am. All right, there we go. So there's the name of the game for your journal, all right? So we're going to go through the first 8 examples that are within your homework. So this will correlate with what I expect you to understand about graphing simple rational functions. Zoom out a little. I just have those words embedded in your mind, what we're doing. It's rational functions. They're formed, the ratio is formed where the variable's in the denominator. They're simple because it's just to a power of 1, the variable is. And we'll do more complicated ones, they call it. They don't use the word complex because that has to do with I. The word complicated means it's you can't just look at the equation and determine the transformations. You got to manipulate it a little bit. So they start off all the examples that this is the parent function. That is a rational function. And that's what we learned yesterday. When you see this equation, you get the curves that we have on our notes there. That we have at the top of our notes. This function makes that picture. Okay? Now, what if I transform it? What happens to the graph is that the entire set of ordered pairs move up 5 units. So the intersection of the asymptotes would be at 0, 5, right? This should be familiar because we've been moving vertices, we've been moving, there's a vertex, there's a curvy, where the pinwheel spins. Okay, now we're moving where the asymptotes intersect. So if you remember, the K out here, he goes up and down, and in here where the H lives, that's left and right. Remember. Bringing back good memories. So now you know what the parent function is. I'm not going to repeat that again. I'm just going to write what the transformed function they give us is. So this is a multiplier. So that means I'm stretching. So they want you to say what direction, because the 3 is the A value, the A, B, H, K is the A. That's the vertical stretch by 3. A, B, H, K. A is the vertical stretch by 3. They already had the word stretch. So you leave it as a whole number 3, because when things stretch, it's being multiplied by a number greater than 1. All that. If I make 3 of you tall, you're going to be, stretched vertically. Okay. But the boxes around, they're going to be drop-down menus for this. And then this you have to fill in. Remember, the values of the factors and the units are always positive. So don't make that mistake. So hopefully this is a familiar exercise in your brain about how these graphs change. Okay, this graph had something happen to the x value itself, and x is crazy. So it's not a positive 2, it's a negative 2. So you put left 2. Again, don't put the negative 2 in here, just say it moved left 2 units. Hopefully you've been working on your homework. Yeah, I knew this stuff. Looking at the examples, I got this. I understand. I hope. See how fast these are going? Yay. Okay, this guy, this is what the software had. He had a decimal in the denominator. That makes me crazy. Because that is, you don't think of it as 2/10. You should think of it as the reciprocal of 2/10. So you can either use your calculator and do the reciprocal itself, 1 divided by 2/10, and you'll get out the answer. Or, I like to change it to a fraction. This is what my brain does. I change it to a fraction first. And your calculator can do that too, right? On the toggle button. You guys know how to do that. I don't know what your decimal's going to be. Mine happened to be 2/10. And so, if it wasn't reducible, yeah, you just write it as a fraction. Like if that was a 3, that'd say 3/10 there. Okay, so you can put in 0.2 and then hit the convert button. And then that's where I got my 1/5. Now, what does that have to do with anything? Well, that is B. B is 5. Because when you're messing with the x, you either take the opposite of what you see or you take the reciprocal of what you see. So because it's next to the x, it's a multiplier. it's a stretch because you're not multiplying by a fifth. You're really multiplying by 5 because of the location of the multiplier. So if you take your, just put 0.2, oh, clear. Flip 0.2, so you're going to get a 5 out. See? That's where that comes from. Either change it to a fraction and flip it, or just straight up flip it. That's how you're going to get your value there. And I knew it was going to be a bigger number than 1 because it says stretch. And I think we said it before, a horizontal stretch is just like a vertical compression. As far as what it looks like, and then, you know, it just depends on what your multiplier is if you're horizontally or vertically manipulating it. What do you got? 4 in the books. Here's the next one. Off to the side, so that's the K. K is normal. So the conversion, transformation is going down 2 units. Notice I didn't put a negative in that box. And I don't remember if very many people did that, but I know enough to do it that I still need to talk about it. Just warn you. Just forgot. Because it's been since last semester we've graphed. Haven't graphed for a bit. Everybody get number 5 in on the notes. Right, here is number 6 that's x minus 7. So you're moving it to the right because x is crazy. 7 units. 1 over x minus 7. See the difference between those two ideas. Notice where the number is. He's on the outside of the fraction. He's under the fraction. That makes a difference on the direction of the shift. Translation is another word to say all those things. All that means the same thing. Right. Number 7 is a pickle. You got to know what's going on here. You got 2 things going on outside of the fraction. So that's A. So it's going to be a vertical compression. And I looked it up during 4th period. Those poor people that got put up with all my warts. I did not look it up before. I looked it up here. And it is a 0.3. Don't have to change it to a fraction, okay, friends? Leave it as a decimal for number 7 in your software. How do you know it was vertical? Because it's the A number outside the fraction story. Now the flip. This I had to look up too because I'd made that mistake earlier. We looked at the graph and you couldn't tell from the graph. So, because the multiplier is got the negative outside the x territory, it reflects across the x-axis. So it's really multiplying the y value, so it reflects across the x. The y values are changing with this negative. If it was down here next to the x, then it'd be the x values were changing, reflecting across the y. Yikes. It's a lot of challenges there. Just got to play with it and think about it. What's changing? And I did not do that yesterday. Okay. Now what's tricky as well, on our notes, that guy was up here instead of next to the parent function. So that's another little trick. Well, is it multiplying the x? That's so challenging. But if it's in the numerator, if the negative's in the numerator, it reflects across the x. Okay? The negative's in the numerator, it reflects across the x. If the negative's on the outside, it reflects across the x. So there's two places. Yep. This is what makes it more challenging on a rational function. Okay, last one. That's a negative. It's 1 over a negative 8x. I boxed out the 8 because remember that's what you're multiplying by, and you got to flip it because it's downstairs there. So it's a horizontal compression by an 8. So the 8 is next to the x, therefore you've got to flip it to talk about it, and it's the horizontal game. Now the negative is next to the x, it's in the denominator, therefore it reflects across the y. I'll have 3 choices there to fill in or drop down for number 8. Tricky, huh? Tricky. Where does the negative live? Rah! Now the rest are, you've got to tell the story and find the graph of the function. So here is number 9. This will be the last one we'll do because it's a lot. It's got 3 things going on. It's got a multiplier of a, it's got an h downstairs, and then it's got a k off to the side. So a, h, and k. And you got to talk about every one of them and what do they do to the original graph. And that makes me sad they have all the same numbers, because then you could start answering questions and, well, they're about the same numbers. This is a positive 3, that's a negative 3, and that's negative 3. So you could be wrong and still get it right and think you're right, but you're wrong. So that's the pickle on number 9. Everybody got their game? This is what we're looking at. Okay, the first thing you want to do, talk about is this number. So that guy is an A, so it's a vertical stretch of 3. And I did not box out what you're going to have to pick. Ooh, I think you just have to put in the 3. There you go. Now they put these two together in a sentence. They say this is a translation of 3 left and 3 down. So those all stay positive because they're units. That's nothing different than 1 through 8, except for there was a lot. Any comments about the directions there? You got to tell me what you're thinking so I can help you better. Yes. Nope. Nope. It'd be 1 left, 2 down. Okay. That's a great question. I'll show you. This number came from here. Because of the plus, you know, it makes it opposite of what you see. Good thought. Because they're all the same, aren't they? This 3 comes from here. And I don't have another good. This is pink, but this pink might be too deep. I'll do it light. That 3 comes from here. Oh man, that's ugly. That's just ugly. My ink just got obliterated. There we go. Okay. Good question. questions. Thank you, thank you, thank you. I didn't even notice that in fourth period that they were all threes and they were gonna, where did you get that three, right? All right. Now, in your next story is you're gonna be talking about the X values. That's the domain. And there's a lot of, I'm gonna show you. There are 1, 2, 3, 4, 5 spaces for the domain story is going to be the same number. And we get that number from what X cannot be. So down here, that X cannot be a -3. So that came from the yellow number there. And so -3 goes in all of the boxes. So you got 5 boxes, you put all the same number in. Because it's either less than -3 or greater than -3, or it's not -3, or it's from -infinity to -3, and positive infinity, or -3 to positive infinity. So, yeah. So I'm only writing it once. You get to put it in the domain story 5 times. Range comes from the K. I'm going to make my pink ugly here. I have to redo. And he gets written in there 5 times. So do it carefully so you don't mistype a negative and have to then send me an email and say, I missed one negative. Now, if you missed them all negative, something's wrong. You know, you don't understand. But if you accidentally didn't type one negative, they're going to ding you on it. So let me know if you made a typing error there. Alrighty. That's where I'm going to leave it. We're not going to talk about the graph find yet, because that's going to take a whole nother page. So, and our time is up. And you guys can at least do 1 through 9. Tomorrow we'll finish the story, which will go quickly because of the, you know, they're all like number 9, I believe. No, there's a couple of drag and drops, I guess. But for the next several problems, you're going to be filling in the blanks like this and finding the graph. So don't make sure you answer all the parts on this question, because if you submit it, it needs everything filled in.